So the main function is y is equals to sine inverse x. So from here, what you can write, okay, so in this problem, find the derivative of the function y is equals to sine inverse x. From here, what you can write down, we can write down x is equals to sine y, right? Here, the main function, which one we have to derivate, that is y is equals to sine inverse x. Here variable is actually x. Indeed, what we have to determine as the function is y, so dy by dx we have to calculate. Right now, if we differentiate in this part, derivate in both sides, so here dx by dy, why dy by dy here? Because in this equation the main variable is y, that's why we have to differentiate with respect to y. So that's why left side as well, the denominator is y, I mean dy. Now dy here at the right side as well, and the function is sine of y. So here, if we differentiate sine y, what we have? We have got cos of y, and here dx by dy. We know that from the differentiation basic formula, d over dx of sine x is equals to cos x. This is actually a formula. Now what we have to determine, we have to determine dy by dx. So now if we inverse this equation or cross multiplication this equation, so we could write down dy by dx 1 over cos of y, right? Cos of y. Here what you can write, we can write 1 over let's take it as cos square y, of course square root, or we could write down 1 over 1 minus sine square of y. We have taken the assumption that x is equals to sine y, so sine y is equals to actually x. Now plug in the value here, 1 over 1 minus x square square root. So this is actually the final answer. So d over dx, and the variable or sine inverse x, right? So this is the final answer. In this second problem, we have to derivate the function y is equals to cos inverse x. Here same way we could write down x is equals to cos of y. Now differentiate both sides, so we could write down dx over dy, it will be dy, equals to d of dy cos of y, because here variable is actually y, that's why we have to differentiate in both sides with respect to y. So we know d of dx cos of x by the formula of differentiation minus sine of x, so it will be sine of y dx by dy. Now what we have to evaluate, as the function y is equals to cos inverse x, so here the variable is x. Indeed, we have to define or determine d of a over d of x, right? So if we would like to find the main objective to find, that is actually dy by dx. So if you'd like to have the value from here dy by dx, just do the inverse. So dy by dx is equals to minus 1 by sine of y. We know that sine squared theta plus cos squared theta is equals to 1. So sine squared theta is equals to 1 minus cos squared theta. So here what you can write, 1 over sine square y square root. So square root square cancel out, so it will become the previous step, 1 by sine y. So logically it is right. Now we can write down 1 minus cos square y and of course square root, and we have taken that y is equals to cos inverse x. This was the main function we have to differentiate, but from here we could write down actually x is equals to cos y. So cos y equals to x, right? So now plug in the value of cos y is equals to 1 over 1 minus x square square root. By the way, we're missing one thing, that is actually the previous line it was minus, because it was minus here from the differentiation formula of cos y. So it will be minus as well, it will be minus as well. So this is the final answer. So d of dy over dx, so this is the final answer. In this example, y is equals to sine inverse, the angle is different, right? So the angle actually square root of 1 minus x over 2. We can solve this problem in two ways. Let's start in a very basic way. So here the angle is actually different, so let's consider this is p. So let p is equals to the angle square root of 1 minus x over 2. So the function looks like y is equals to sine inverse p. Now if we differentiate dy, because here the variable is p, so it will be dp sine inverse p, and we have to differentiate, so let's say here d and the variable is dp. So the very first problem or example, we have to differentiate this part, so we can write down 1 over 1 minus p square, as the variable is p, so it will be square root. Now actually p is not p is equals to actually this part, right? So let's go down a little bit. So what you can write down, we can write down 1 over square root of 1 minus, let's plug in the value here. So the value of p is actually 1 minus x over 2 whole square root whole square, because p is square here. So square root and square cancel out. So what we have here, 1 whole square root 1 minus x over 2 here. So the following line will be the LCM of this. So here will be 1. Actually, let's do one thing here. The LCM will be 2. So it will be 2 minus 1 plus x. So what we have got here, 1 over 1 plus x over 2 under square root. So this is actually the value of dy over dp, right? But this is not exactly what we are looking for, because p is equals to actually square root of 1 minus x over 2, right? Now what we have to do, we have to calculate the differentiate value of this part. Indeed, what you can do, let's differentiate dp over dx, because the variable is x, right? So d of dx and here square root of 1 minus x over 2. So the basic formula of derivation for x to the power n. So this is the formula is n x to the power n minus 1, n dot x to the power n. So here the main variable is this part, right? So what you can write here 1 minus x over 2 to the power half. This half is actually n, so half here and half minus 1, and we have to differentiate this inside part as well. So d over dx 1 minus x over 2. Here half, and you can write down 1 over 1 minus x over 2 square root dot what we have got from here, this is half, and so it will only half from this part, right? And here what you can write down, we can write down 1 over 4 because 2 multiply 2 is 4, and 1 over square root of 1 minus x over 2. So here actually the value is d of p over d of x, right? So this is the value of dp over dx, and here we have got dy over dp. But what is our main function, by the way? Our main function is y is equals to sine inverse square root of 1 minus x over 2. So we have to define or determine d of y over d of x, right? Because the variable is x and the main function is y, that's why we have to determine the value of dy by dx. Now if we determine the final result, that is dy over dx, we could write down dy over dp dot dp over d of x. This is actually a chain rule. This is called chain rule of differentiation. Anyways, now plug in the value of dy by dp, that is actually 1 over 1 plus x over 2, this value actually, and dp by dx, that is this value 1 by 4 over 1 by, so let's plug in here the value. So what you can write down here, 1 over 4 square root of 1 minus x over 2. Now what you can write down here, so it will be 4 of course, and here of course square root, then 1 minus x square, because a plus b, a minus b, so a square minus b square, and it will be 4 and it will be 1, right? Okay, so what you can write down here, 1 over, so we can write down 4, and when it is coming out from the square root, we can write down here 2, and here will be 1 minus x square, right? So the following line will be 1 over 2 of 1 minus x square, right? So this is actually the final answer of dy by dx. dy by dx. Let's check. So this is the final answer, right? Now if we go through to cross check whether we have done any mistake or not. Indeed, start from here because this is the complex part actually. dp by dx, so d of dx 1 minus x over 2 square root. So this is actually, we have to follow this formula because this part is to the power half because it is under square root, right? So the definition here, half, because n is half, 1 minus x, this is done. Now we have to differentiate that inside part, I mean 1 minus x over 2. So here what we have made a mistake here, we can see that when we differentiate this part, let's do again this part, d over dx and 1 minus x over 2. So if we differentiate like first half, then minus x by 2, so half is a constant, so this will be 0, and then minus x over 2, right? So if we differentiate, then we have minus half, so it will be actually minus half, not plus half. Indeed, we have a minus here, so our final result will be, of course, here minus, and this part plus minus, so minus, so this is minus everywhere, so the final answer will be minus. So this is the answer.